Welcome back. In this video, I am actually going to start the course on the Python language itself. Now, I have in front of me here the Anaconda Navigator, which we are going to use as a launching pad for the Jupyter Notebook. As you can see, when you open the Navigator, you will have a number of IDE already pre-installed. Some are actually available in the Navigator, but they are not installed. And to install them, you just need to press on the install button for these individual packages. There is a lot of these packages available. Mine is Jupyter Notebook, therefore I will only be using Jupyter Notebook. Now, how do I get to this page? To do that, I will navigate to my start button, and then I will find a navigator within Anaconda itself. As you can see, it's Anaconda Navigator. By pressing on this Anaconda Navigator, I end up coming to this page here. Now, to go further from here, just click the Jupyter Notebook launch button, and this should take us into the web browser that you will assign as the default web browser for Jupyter Notebook to be opened in. My preferred web browser is Google Chrome. Therefore, by pressing on this launch for Jupyter Notebook, it should bounce open on the web browser. And as you can see, once it opens in the web browser, you will have this page that appears in front of you. And as you can see in this here is the root of your computer, and it will show you all the folders, all the files that are installed on your computer. Now, I have already created a folder on desktop, which I have some notebooks pre-prepared for this course available on desktop. Therefore, by actually clicking on desktop, this will take me to the desktop folders, and in there you can see it shows all the folders that I have on my desktop. Now, by clicking on the folder that I have created for this course, then I just create there, and you can see I have already some folders within this mastering machine learning folder, and I have some Jupyter notebooks already there, and I have some folders which I have created. Now, my course Jupyter notebooks are actually within this folder course, and if you see, if I click in there, it should take me to this folder, and the content in this folder is Crash Course Jupyter notebooks, which I have prepared 4 of them for you, and I will be sharing these Jupyter notebooks with you, and they will be downloadable from the channel. Now, how do we initiate and start the Jupyter notebook so we can actually start using it? Now, there is 3 ways to start the Jupyter notebook. One, if it's already prepared in your folder, you just have to click on that and it should open for you. And the other method is to actually create a new Jupyter notebook, and all you have to do is just navigate to these buttons here, and you can see it actually says new. If you click on that, then it gives you the option of creating a Jupyter notebook with Python kernel, and our Python kernel is Python 3. Therefore, if I click on that, it should create a new Jupyter notebook as this, and as you can see, it goes and initiate it, and it will be titled untitled, i.e. it doesn't have a title. Now, to title that, then you click on this title and you can name it whatever you want, and let's say I will name it Naim. Okay, and by pressing there, then I have actually a Jupyter notebook that's called Naim, and in there I can actually start coding and adding and creating some code which I can execute. And as you can see, I have just executed the first statement. Very simple. I just wrote 3 plus 4 and I hit the run button, and it actually gave me this result. Or I can say print and within the print statement I can decide what I want to actually. Let's print a string and let's say hello and welcome. And then you hit that and you can see now I have actually hello and welcome. Next I can actually define a variable a, and then I can assign to that some values. Let's say 3 plus 4, which what we have there at the beginning. And now if I execute this, no output, but it executed correctly because it didn't give me an error. If there was an error in this execution of this cell, it should have given me an error. As you can see, there is no error here. So what happened? It actually went and executed. What it did, it actually took 3, added it to 4, and then assigned the total result into A. So if I want to show this, I can type A and I run, and it should give me the result. Or I can use the print statement as I did before and just put A there and print A, and it will run. Now there is a difference between doing it this way and doing it that way to display the result. If you look here, once I actually entered A, it actually just gave me a 7, and next to the cell it says this is the output of cell 4. While when I use the print statement, it didn't give me anything here because I intended to actually display the output of this cell. And I can go a number of cells afterwards, and I can do print A and execute that and still give me, and it doesn't have to tell me it's actually the output of cell 4, because I can do it in any cell later on. It's an intended. I actually know what I am doing, and that's why it actually done that way. Now, the second method to the third method of opening a Jupyter Notebook is if you have a Jupyter Notebook that's already supplied to you, which you've downloaded from GitHub or from the link which I provide in the channel, then you just hit the upload button and it will open for you the folders which you have. You have to decide where do I need to go. Let's go to desktop. I have some work that I have done previously on some notebooks. So let's see, if I go to desktop and I go to chest CT scan images, and if I hit that, I have some Jupyter notebooks there. So all I need to do, let's say I actually select this untitled notebook and I can open that. It opens, and as you can see, it needs confirmation from me. Shall we load it or not? Because maybe I made a mistake and it's not this notebook that I want, and I want another one. So I can cancel or folder, and let's hit the upload. It says there is a folder already there with that name. Do you want to overwrite? I can say yes, and it will overwrite the untitled Jupyter notebook that we had before. If I now want to open this Jupyter notebook, all I have to do is just double click on that and it should open this Jupyter notebook for me, as you can see here. And the Jupyter notebook should have the code that I have already prepared for this work on some medical images. Okay, so this is how we open these Jupyter notebooks. I'm going to close these Jupyter notebooks and I am going to go back to my crash course. I want to get rid of these two Jupyter notebooks, therefore, because I don't want them to clutter the folder which I have already prepared. Therefore, I will delete them. To delete them, I just selected them and then I will use the delete button as such, and it just gives me a confirmation and I will say please go ahead and delete. So now I am back to the folder with the Jupyter notebooks which I want to introduce to you. And I am going to start with the first Jupyter notebook, which is part 1 on the crash course. So if I select that, it should open and we can go and start our course from now on. Okay, so now we have opened our Jupyter Notebook. I can start with the material that I have prepared for you. Now, as you can see, I started by introducing a simple mathematical operation where I'm adding two integers together and just displaying the result for them. So I just wrote this mathematical operation and then I hit the run button. Now, what I didn't show you in my initial presentation of this video is actually the location for help. And it's very important for you to see that there is a section here which is actually on keyboard shortcuts. And I advise you to actually go into that keyboard shortcuts, because I know most of you would like to have shortcuts. You don't like to use the mouse and jump from one location to another, where if you have your hands on the keyboard, you can actually use this shortcuts to maneuver within the notebook. But what I wanted to actually talk about is how to run these cells. Now, to run a cell, there is two methods. Either I hit the run from here, or I will use Alt and return as such, and it should run this cell. So it's up to you how you want to do it. The next thing I wanted to talk about is actually variable assignment. Also, I have introduced this by saying I created a variable A, and then I assigned to it the values of 3 plus 4, and I showed you how we print that. Now, in this section here, I am actually going to create three variables. Variable A, variable B, and a variable I named sum underscore AB. I assigned to the first variable 7, to the second variable 3, and then I did a mathematical operation, and the result of that mathematical operation, I assigned it to the variable sum of AB. And next statement was actually the print statement, and I presented two print statements here. The first print statement was actually on just showing the result, and the second print statement I added some text, informative text, where it can tell me this result is what. Okay, and that's very important, because a lot of us, when we are actually working on this code, we know what we are doing. But as you know, as programmers, if you leave this code for a month or 2 months or a week, or maybe even 2 days, and you are a busy person and you have too many codes that you are working on, you come back to your code and you forget what you are doing. Therefore, you need to format your print statement to tell yourself and to tell others what is this result means. And to do that, all you have to do is just to insert a string, and in that string you can actually inform the viewers what this number that appeared on the screen, or what this result. It doesn't have to be integers or float, or it could be anything, or it could be an image. You need to tell them what this image means. Why is it actually popping here at this stage within your code? And then I use the comma and I put the actual variable that I want to print. So when I hit this run, then it should actually give me the result of these two print statements. It will not give me anything else, because there is no result to display here, there is no result to display here, and there is no result to display here, because the action was only to assign these variables into these values into the variables themselves. There was no display, there was no need to display. Okay, so if I hit this run, you can see now I have 10, which is the result of this print statement, and then I have the formatted result, which says sum of A and B, and it gives me the result, which is the result of executing this cell. Now, as you can see here, I wanted to actually show the content of this variable a. Therefore, I just type the variable a and I run the cell, and it should give me this result here. As you can see, when I run it, it actually gives me the result. So if I go and comment this here, okay, and comment this print statement here, and if I run this, it doesn't give me anything. It actually ran, it opened a new cell for me, but no result was displayed. Now, if I type here sum underscore a b, and I run this again, then it actually gives me 10 because I actually use this statement here to show me the content of that variable. So this is how we actually utilize our print and visualization abilities available within Jupyter Notebook. Now, I can also go further. I can create another variable and print. Now, let's say I have created a variable and I wanted to print it, and I went and hit the run statement here. As you can see, it didn't give me anything. It gave me an error, and it says there name y is not defined. But it's already there, and I tried to print it. But if you check that I haven't created this variable, what I should have done, I should have created y, which is simple by just introducing the variable y, and then I should have assigned something to this variable y, and I could say that it's actually just a string hello. Now if I try to run this, it will actually give me the content of y, and as you see, the content of y is not numbered, it's not integer, it's not float, it's actually just a string. So I can assign to this variable not just numbers as I did here, but I can assign anything to this variable that I have created. So now we have seen how to create variables, and you can see it's very simple compared to what you have to do in other languages. You remember in C language we had to go and define the type of the variable that we are actually introducing by saying, for example, int, and then after that I would say y, and then I will use comma, and then x, and so on. And I can go and in Python we don't have to do any of this. All we have to do is to actually write the variable, and it's created, and we can use that variable. I am actually removing these empty cells to make it continuous, this Jupyter Notebook. And to remove a cell, all I have to do is just to use this scissor sign button, and it will cut the cell from the Jupyter Notebook. Now, in the next cell, what I have done, I have actually introduced 4 mathematical operation: addition, subtraction, multiplication, and division. And I created a variable for each of these operation: result addition, result subtraction, result multiplication, and result division. And I use the operators plus, minus, asterisk for multiplication, and slash for division. This is how simple it is to actually do it in Python. Now, if I execute this cell, you should see that it will actually display the result for me, and the result is something by itself, because when I look at the result, it was an integer for the first addition operation, it was an integer for the subtraction operation, and it was an integer for the multiplication. And why? Because I only used integers to do these operations. If I change the type of what I have used here, let's say I will add 3.5, and if I carry out the multiplication, now you can see that the result of this addition, now it becomes a float, i.e. I have a decimal point because I introduced a value with a decimal point. Therefore, the result is going to be a float. Now, if I do the same here and introduce a decimal point, if I run this cell, the actual multiplication will become, and the addition and subtraction and division, it's all the same. But even in the division, when I use two integers, the result could be an integer, but at the same time it could be a float, because if I said 7 divided by 2, or 9 divided by 2, an odd number divided by 2, then the result is going to be a float, and that's why it comes as a float in this case. So it's very important to actually understand, even though you are using integers, some of the result might be floats, which is something that can happen by default. Okay, the next statement which I introduced is a mathematical operation, and it's power of. And to actually bring something to the power of something, we will use the double asterisk here to actually indicate that its power. So the Python compiler here takes these two asterisks, and it will say we have something and then power of something. So that means it's 2 to the power of 3, and it's important. So I can change that to 8, and I can change this to 10, whatever I want, and it then becomes, in 2 to the power 3, it becomes 8 to the power 3. If I don't want to do that, I can actually declare a variable y equals 3, and I will say it 8 to the power of y, and then y is a variable that I can assign anything in there, or it could be the output from a function, and it could be called and used in there. So this is how you do it, and let's bring it back to reasonable numbers rather than this 8 to the power 10. Now, we know the result of that is going to be 8. Therefore, if I execute that, it should give me the result. Now, if I comment this, and if I run this, I should get nothing, because I didn't ask for it. I can go in another cell later on and use this, and I will say print and in here, if I run this, then I get the result, or I can just say results, which is the same. It should give me the actual output. So whatever way I want to do it, I should be able to do that without a problem. So next, I want to actually return the mod of some mathematical operation. So what I want to do, I want to get the modulus of the division of 15 by 4. Now we know that division of 15 by 4 is actually 3 point something, okay, because there is 3 4s in 15s plus 3. So I want this remainder. That's all I want to return, and we call that modulus in mathematics. So what I have done, I use this operator, which is percentage, which will actually return for me the modulus. So it will assign the modulus of this division, this operation, into the variable result underscore module. Therefore, if I run this, it should actually give me 15. Now, if I change that into 8, and if I run this, I will get 0, because there is no remainder. The result of dividing 8 by 2, 8 by 4 is 2, and there is no remainder. So remainder is 0. Therefore, it returns 0 for me. So it's important to actually understand that. So if I make this into 11, then it should actually see it's going to be 3. But I said also 15 is 3. Is that right? Yes, because we are looking at the remainder of this division operation. So what I want to say is you can use this percentage sign as returning the remainder of some operation, division operation, as we showed here. Okay, so the next operation is actually an order operation. I put a very simple mathematical operation here in which I want to do an addition and a multiplication operation. It's a little bit more complicated than seeing an addition or subtraction operation. And what I want to say here, when you as a human being want to do this operation, this simple mathematical operation, you will actually look at the bracket, then you execute the operation within the bracket, and then you go outside and execute the operation outside the bracket. And this is exactly how Python will do it. It will actually look at the brackets and will say there is a priority there, and it will execute the content of that bracket. So it will say 4 plus 5, and it will be 9, and then it will multiply this 9 by 3 to give you 27. But if I remove the bracket, then the result will be completely different. Let's see what the result of this operation. As you can see, it's actually 27. Now I will change the order of this operation. And now if I want to do this operation, there is no bracket. Therefore, the compiler will have to define the priority. And the priority is actually multiplying these two numbers and then adding the other number, which is 4. Therefore, in this case, the result will be different. And as you can see, it's actually 19. Why? It's 8 times it's 19. 3 times 5 is 15, and you add the 4 to that will give you 19. Even though I didn't put a bracket around this, the priority between this multiplication and the addition is chosen and selected by the operating system, and we call this priority. So if I bring this back as it was, okay, and then I can change this and put a bracket here, a bracket, not an asterisk, and then add something or subtract something, and let's say -1, and now do this operation. It should actually give me a different result because I have two priorities. First of all, it will add this and it will get 9, then it will subtract this number from this number and it will get 2, and then it will carry out the multiplication. Therefore, it's important to understand that there is an order to these operations, and you need to write your expression, your mathematical expression, clearly as you want it to be executed. Otherwise, you might get the wrong results. Therefore, it's essential to follow structure when you are ordering your mathematical operation, a structure that you decide on and you say, this is how I want to execute this mathematical operation. Next, I will be introducing the Boolean variables. And you know, we only have two variables in Boolean, true and false. And in computer science, this means 1 or 0, because the computer deals in bits, and the bits is either 1 or 0, and you can have more than one bit to make a nibble or a word or a byte and so on. So this is a different topic which I wanted to go into that now.